At a JPL tracking station outside Pasadena in October of 1980, a deep space analyst noticed that a spacecraft launched 8 years earlier was not where the math said it should be. The discrepancy was about 1/10-billionth of Earth's surface gravity. A spacecraft cruising past the orbital distance of Uranus appeared to be feeling a tiny extra pull toward the sun. He wrote it off as a calibration error and went home. Over the next 32 years, the same anomaly would be found in the tracking data of 2 separate spacecraft, would be published in physical review letters, and would not be explained until 2012. This is the cold archive. Pioneer 10 launched from Cape Canaveral on March 2, 1972. Built by TRW Incorporated in Redondo Beach. Operated by NASA Ames Research Center in California. Tracked by the Jet Propulsion Laboratory. Its mission was Jupiter. It flew through the asteroid belt without incident, the first spacecraft to do so. In December of 1973, it passed within 130,000 kilometers of the cloud tops and kept going. Pioneer 11 launched 13 months later, April 5, 1973. Same hardware family. It flew past Jupiter in 1974 and past Saturn in 1979. Then it too kept going. By the early 1980s, both spacecraft were beyond the orbital distance of Uranus, on outbound trajectories no human-built object had ever taken. Their only contact with Earth was a narrow microwave radio signal transmitted by an 8-watt amplifier.
From a JPL Deep Space Network technical brief. At 40 astronomical units, the Pioneer downlink arrives at Earth attenuated to roughly 10 to the minus 21 watts per square meter. Doppler precision is preserved by the carrier frequency, not the signal strength.
The Deep Space Network is 3 radio antenna complexes spaced around the Earth. Goldstone in California, Canberra in Australia, Madrid in Spain, so that at any moment at least one of them can see any spacecraft past the moon. By measuring the Doppler shift of the carrier wave that comes back, the network can determine the spacecraft's line-of-sight velocity to within a fraction of a millimeter per second. By 1980, that precision had become enough to see something small. What it saw was this. Pioneer 10's measured Doppler shift was consistently slightly different from the Doppler shift predicted by the gravitational model. The difference was equivalent to an extra sunward acceleration of about 8.74 times 10 to the minus 10 meters per second squared. That is roughly 1/10-billionth of the gravity you feel standing on the ground. It is also at the precision the Deep Space Network had reached by 1980 above the noise floor of the tracking system. Pioneer 11, on a different outbound trajectory, showed the same anomaly. Same direction, sunward, same approximate magnitude, 2 independent spacecraft, 2 independent tracks, 1 residual. That is the moment the discrepancy stops being a calibration question and starts being a physics question. The JPL team began checking everything they could think of. Atmospheric drag, solar radiation pressure, fuel leaks, software bugs in the orbit determination code. Each candidate they could rule out, they ruled out. By the mid-1990s, the residual was still there, in the data of both spacecraft, and nobody had a clean explanation. In 1998, a JPL group decided it was time to publish.
From Anderson, Lang, Lau, Liu, Nieto, and Turyshev. Physical Review Letters, Volume 81, page 28, 58. 1998. We report an apparent, anomalous, constant sunward acceleration of magnitude approximately 8 times 10 to the minus 10 meters per second squared.
The paper put the anomaly on the table. It did not propose a mechanism. It said, here is the residual, here is what we have ruled out, and here is what is left. The community gave it a name, the Pioneer Anomaly. Between 1998 and 2012, 2 questions stayed open. 1. Is the residual a flaw in the tracking model, the thermal accounting, or the spacecraft engineering? 2. Is it a signal of new physics, modified gravity, dark matter, or something we have not yet named? Meanwhile, the spacecraft kept transmitting until they did not. Pioneer 11's signal stopped on November 24, 1995. Pioneer 10 sent its last carrier wave on January 23, 2003. 3 serious explanations were on the table by the early 2000s. Each one had to match the magnitude of the anomaly, its direction, and its persistence across 32 years of tracking. Each one failed at least one constraint. Hypothesis 1. Modified gravity. The framework called MOND, Modified Newtonian Dynamics, was proposed by the Israeli physicist Mordechai Milgram in 1983 to explain galaxy rotation curves without invoking dark matter. It predicts a regime where Newton's law deviates at low accelerations. Pioneer in the outer solar system is at low acceleration. A MOND-style modification could in principle produce a small extra sunward pull. The numerical magnitude lands in roughly the right range. For a while it looked plausible.
From a 2006 review by Robert Sanders. The Pioneer signature is not a clean MOND signature. The anomaly does not vary with heliocentric distance in the way a MOND prediction would, and the direction is precisely sunward rather than along the spacecraft's velocity vector.
Hypothesis 2. A dark matter concentration in the outer solar system. If cold dark matter were gravitationally clumped beyond Saturn, the gravitational pull of that clump would add to the sun's pull on an outbound spacecraft. The size would scale roughly like the anomaly. The constraint that breaks it is the planets themselves. The orbits of Saturn, Uranus, and Neptune are tracked to extraordinary precision. Any dark matter concentration large enough to perturb Pioneer would perturb those orbits measurably. Lorenzo Iorio published The Limits in Classical and Quantum Gravity in 2007. The planets show no such perturbation. Hypothesis 3. The spacecraft itself. Each Pioneer carries 4 radioisotope thermoelectric generators on extended booms, RTGs, which produce electricity by thermally coupling plutonium decay heat to thermocouples. Each RTG is also a heat source. The electronics compartment is also a heat source. Together, the spacecraft dissipates roughly 2,000 watts of thermal power into the vacuum of deep space. That power leaves the spacecraft as infrared photons. Photons carry momentum. If they leave asymmetrically, the spacecraft feels a recoil. The Pioneer geometry is not symmetric. The high-gain dish antenna points back toward Earth and is therefore broadly opposite the direction of outward travel. Heat that bounces off the back of the dish or escapes around the dish has a preferred direction. If more infrared photons leave on the antenna side than on the deep space side, the recoil pushes the spacecraft slightly toward the sun. The magnitude of that recoil on a Pioneer-class spacecraft is in the right range to match the anomaly. The question was whether the geometry actually closed it. That question required a full, three-dimensional thermal model of the spacecraft. It required the original engineering drawings, the actual material properties, and a reanalysis of the entire Pioneer 10 Doppler dataset extending back to 1979. By 2012, a JPL group had all 3.
From Turyshev, Toth, Kinsella, Lee, Locke, and Ellis. Physical Review. Letters 108, 241101, 2012. The reconstructed thermal radiation force is consistent with the observed acceleration. No new physics is required.
The Turyshev paper showed that the thermal recoil force, when modeled across the full mission profile with the time-dependent decay of the plutonium fuel and the changing electrical load, accounts for the residual. The fit is good. The anomaly closes. Modified gravity is not required. Dark matter is not required. The spacecraft was radiating photons preferentially in one direction, and the recoil was pushing it back toward the sun by 1/10-billionth of Earth's surface gravity. For 32 years. The Pioneer anomaly is resolved. It is also a record of how thin the margin is between a residual that hints at something new and a residual that, given enough engineering accounting, dissolves back into the noise. For 14 years between 1998 and 2012, nobody knew which side it would land on. Pioneer 11 fell silent in 1995. Pioneer 10 sent its last signal on January 23, 2003. Both spacecraft continue on their final trajectories. Pioneer 10 toward Aldebaran. Pioneer 11 toward Aquila. Ballistic. No longer tracked. Going where the equations now say they should. Wednesday's case. 1587. A colony of 117 English men, women, and children landed on an island off the coast of what is now North Carolina. 3 years later, a ship returned to find the settlement abandoned. No bodies. No signs of violence. Only a single word carved into a wooden post. Croatoan. The Roanoke Colony, Wednesday 8 p.m. Eastern. See you then.